Mastermind presents. Hey guys, how are you? Let's start with our very first chapter, that is number system. As you know, we have done our first exercise, that is 1.1, in which we have learned the rational numbers. Now let's begin with our next exercise 1.2, in which we will learn the irrational numbers. Let's first see on the definition. The irrational numbers are the those which we can't show in the P over Q form, where P and Q are not the integer, and Q is not equal to 0. Let's begin with the examples like under 2, 3, root 15, pi, 0.101101, and so on. Here, the usually irrational number is denoted with the sign which is known as the root. We assume that the positive square root of number. For example, we all know that 4 is equal to 2, but even it's also the root of -2 because when we multiply -2 with -2, we will get the answer 4. And one thing more that we have to learn of this line, which tells that every real number is represented by a unique point on number line. Also, every point on the number line represents with a unique real number, which means that for example, these two lines officially mean that, for example, the under 2 -1, 4 over 5, -8 over 3, -6. That means all these numbers are shown on the unique point on the number line. This line indicates that. Now, the most important part of this exercise is to locate the irrational numbers on number line. Let's see how we will do that. For example, we have a number line. I name this like this. Okay. Now I have just this is 1 centimeter, and we also have made 1 centimeter here. That means this line is equal to this line. Both are 1 centimeter each. Okay. Now I will join them, and this will be under 2, and this will be change, and this become our radius from the 0. By opening our compass, we will just we will just make this circle in which it cuts the line, and we name it as star. Okay. Now, by the Pythagoras theorem, this star indicates equal to √2. How this is? Let me show. We know that h square is equal to base square plus perpendicular square. Now, we have hypotenuse. We don't know the hypotenuse, just we know this 1 centimeter height. This 1 square plus this 1 square, which will become 1 plus 1, 2, and here to become 1. This shows that this line is under 2, and we have to locate this under 2 on the number line. So we just use the compass and cut the line. In the example 3, we have seen the same thing that I did, and from this we can also locate the under 3. For example, here we make the under 2. Now this line is under 2, this line is 1 centimeter. Okay, so this 1 centimeter, we make the same line of 1 centimeter here, which is perpendicular to line there. That means it makes 90-degree angle. Now we will join this line, and from this now using compass we can just cut this line, and which shows the under 2. In the example 4, we see the same situation. Now let's memorize all the things by just solving our exercise 1.2. As we know all, let's begin with exercise 1.2. First question is here. Every irrational number is a real number. That's true. That means all the irrational numbers, whether it's rational or irrational, means irrational number and rational number form together to make the real number. That is why it is true. Now the second point. Every point on the natural number is in the form of root m, where the m is natural number. That is false. For example, like there is under root 9. I can show this is 3. Okay. Now, what if there is under root 2, which has which is a rational number, so we can't show them as in the natural number. That is why this is false. Now the second, every real number is an irrational number. That is false. I told you earlier that rational number and irrational number form together to make the real number. So it's not possible that all the rational numbers are equal to irrational number. So this statement is wrong. Now our second question. In the second question, it tells us all the square roots of all possibilities is rational. It's not given example of the square root of a number that is rational. For example, like under root 2, 9 is equal to 3, under root 4 is equal to 2, under root 25 is equal to 5, under root 625 is equal to 25, and so on. So this shows that all these are the square root of all possible integers. Like 9 is integer, 625 is integer, 25 is integer, and the same with 4. I have the square root of number which is rational number. Okay. So now the third, in which we have to show the under 5 can be presented on the number line. We have to show the under 5 on the number line. Under 5 on number line. So we have taken number line 0, 1, 2. We have made the under root 2, then under root 3, then under root 4, and in the end we will form the under root 5. I make a rough diagram. You can show it clearly. Like here you can show